In this question, we have been given a velocity time graph. Velocity is on the y-axis. We need to figure out the final displacement of the body. So the approach is very simple. Whenever we have been given a velocity time graph, we need to find the area under the graph in order to figure out the displacement. In this graph, you can see that the total time taken is 9 seconds. We need to figure out the total displacement traveled by the particle. All we need to do is find the area under the curve. And how do we do that? Consider this triangle. We will try to find the area between this triangle and the x-axis. So first of all, let me shade that region. This region is going to get us the displacement of the object from 0 to 6 seconds. Let's try to find the area of this triangle. Base of this triangle is 6 units and the height of this triangle is 10. Area of the triangle, you remember, is half base into height. So let us write total displacement from 0 to 6 seconds will be equal to half multiplied by base. Base of the triangle is 6, height is 10. And if we simplify this, we will get 30 meters. And likewise, we also need to figure out the area between 6 to 9 seconds. So let us shade that region first. So this entire triangle, whose region I am shading right now, this area will give us the displacement value from 6 to 9 seconds. Now consider this triangle. The base of this triangle will be 9 minus 6, which is 3 units, and the height of this triangle will be 10 units in magnitude. Area, of course, is always positive. So let's write down the total displacement of the particle from 6 to 9 seconds will be half into base of this triangle will be 3 units multiplied by the height, which is 10. Now, if we simplify this, we will get 15 meters as the answer. But while solving area-based questions, it is very important to note that consider this particular triangle since it is above the time axis. So the area which we have considered 30, displacement will be positive 30. Why positive? Since the area is above the x-axis. Similarly, this entire triangle which is below the x-axis. Now, since it is below the time axis, we will put the displacement value as negative of the area of the triangle which was found. We had found the area of that triangle to be 15, but since the triangle is below the time axis, we have to put a minus sign in front of 15 meters. Hence, displacement from 6 to 9 seconds will be negative 15 meters. And what is the significance of negative sign? All it means is it is traveling towards the left hand side. So the sign convention which we are using is positive displacement means objects moving to the right hand side, and negative displacements would be the particle traveling towards the left hand side. But in the question, we were supposed to find the final displacement of the body, which is total displacement. So let's write down the total displacement from 0 to 9 seconds will be 30 plus negative 15. All we have done is added the two displacements in the first two parts. And if we simplify this, 30 minus 15 will give us 15. Positive 15 to be specific, which means we can say that overall the particle has traveled 15 meters to the right of a point which can be considered as the origin. Next off, we have to also describe the motion of the object, and that is very easy to deduce since we have been able to find the value of displacement. So from 0 to 6 seconds, the displacement was positive 30. That means the particle traveled 30 units to the right hand side. From 6 to 9 seconds, the particle traveled 15 meters, but to the left hand side. So overall, if you tabulate all this information, we can deduce the following. So look at this table. From 0 to 3 seconds, the velocity, observe the velocity from the graph. Original velocity was 0. It increased to 10 meters per second in a span of 3 seconds. So from 0 to 3, velocity increases from 0 to 10, and the distance traveled during that time will be positive 15. And why is it positive 15? Because earlier we had figured out that the total area of this triangle was 30. So if we try to figure out half of this area, that will be 15, which means total distance traveled by the particle in the first 3 seconds will be half of the big area, which is 30 upon 2, hence 15 meters. Similarly, from 3 to 6 seconds, the total displacement traveled by the body will be again half of the area of the triangle, which is 15 only. And also we saw at 3 seconds, the velocity was 10. And as time passes by, till 6 seconds, velocity drops from 10 all the way till 0, which I have mentioned here. From 6 to 9 seconds, the analysis will be a little different. And why is that? Because this area is below the time axis. So please observe that after 6 seconds, this graph of velocity is going below the time axis, which means velocity is becoming negative. And whenever velocity has a negative sign, that means the object has started moving to the left hand side. So from 6 to 9 seconds, the velocity magnitude, although is increasing from 0 to 10, but the direction is towards the left hand side. Now, let me draw a diagram to describe all this information. So, first of all, in the graph, let me label few points A, B, C, and D. So, from A to B, which is 0 to 3 seconds, the particle has traveled a total distance of 15 meters. So, let's draw the diagram. Let's say the particle starts from point A, it travels 15 meters to the right hand side to reach a point B. From B to C, which is 3 to 6 seconds, the distance traveled was 15 meters again to the right. So in the diagram, we can show particle is traveling 15 meters again to the right hand side to reach a point C. Now you can see that the total distance traveled is 15 plus 15, which was 30, which we had earlier deduced from the area of the triangle ABC. After the point C, now look at the graph. The graph is below the x-axis. We had figured out the displacement was negative 15, which means once the particle reaches C, the velocity is 0, which you can see in the graph. So the object stops at the point C, after which the velocity will change the direction. And why is it changing the direction? Because if you observe C, velocity to the left of C is positive, but velocity to the right of C is negative. So what will happen at C? The velocity instantaneously will be 0. The object stops and then it starts traveling towards the left hand side, and it is going to travel a distance of 15 meters, which we had earlier figured out as the area of this triangle. But since the area was below the time axis, that is why we put a negative sign. And the importance of minus sign is the particle is moving towards the left hand side. And if we go back to the question, we were supposed to find the final displacement of the body. If you recall, what is displacement? It is the straight line which connects the start point to the end point. So in this graph, so in this diagram which we have made, A is the start point and B is the end point. If we try to connect both of these with a straight line, this will be the total displacement. And what will be the value of that? You can easily see that is 15 meters, which can be found by 15 plus 15 minus 15 to get us 15. But displacement is a vector quantity. Direction is also important. So whenever the question asks final displacement, we have to say the particle has traveled 15 meters but towards the right hand side. And why right side? Because you can see the end point, which is B, is to the right hand side of A. And the logic is simple. Whenever the end point is to the right hand side of the start point, displacement is considered positive. An object is traveling with a velocity of 5 meters per second, then it accelerates to 15 meters per second in the same direction. And we need to figure out what is the correct acceleration time graph for this motion. So in this, initial velocity is given as 5 meters per second and the final velocity is given as 15 meters per second. So let us write it down. Initial velocity is 5 and the final velocity of the object is 15 meters per second. How do we determine the correct acceleration time graph? So we need to go back to the basic logic, which states that the area under the acceleration time graph gives us the change in velocity, which means one of these graphs is going to give us the right value of the change in velocity. In the question, initial and final velocities were given. Let us try to find the change in velocity. Change in velocity, the formula is final velocity minus initial velocity, which we can write as 15 minus 5. Now remember, velocity is a vector quantity. We have not considered signs into consideration here because in the question they have specified that the velocities are in the same direction. So whenever the question specifies this information, then signs does not have any role to play. Change in velocity will still stay the same. So in this case, change in velocity will be 15 minus 5, which will get us 10 meters per second. Now, all we need to do is try to figure out the area under the graph for all the four options and then check which area is equal to 10. Let's look at option A. Now, we need to find the area between this triangle and the x-axis. So, the base of this triangle is 5 units and the height of this triangle is 10 units. First of all, let me shade this region. This entire region will give us the value of change in velocity. So, in this case, let's try to find the area of triangle. That will be half multiplied by 5 multiplied by 10, and if we solve this we will get 25 as the answer, which means the change in velocity is 25, which is not equal to 10 which we needed. Hence option A can be definitely discarded. If you look at option B, the area again will be 25 only, since the base of the triangle is 5 units only, because it is 6 minus 1, which is 5. Height of the triangle stays the same at 10. Hence we can say that the area of this entire triangle is 25 units. So exactly the same as in option A, which means option B can also be discarded. In option C, The area which we have to consider is not a triangle but a rectangle. Area of a rectangle is base into height. Base of this rectangle is 2 units. As you can see, 4 minus 2 is equal to 2. And the height of this rectangle is 10 units. So area of this rectangle will be 2 multiplied by 10, which is equal to 20. Hence, the change in velocity for option C is 20, which is not the same as what we had required. We need 10. Hence, option C is incorrect, which means definitely option D has to be the answer. But in any case, let us try to figure out the area for the graph in option D. Base of this rectangle is 2 units and the height of this rectangle is 5 units. So the area will be just 2 into 5, which will give us 10 units. Hence, the change in velocity for option D comes out as 10, which is exactly what we needed based on the information which was given in the question. We had deduced the change in velocity was 10, which matches with option D. Hence, D is the right answer for this question.